All right, I'm going to go ahead and get started here. Thank you all for coming today. My name is Aaron Smith. I am really excited to be here. Um, so I am covering for Kathan today because he's out of town. And so I just wanted to make you guys aware that I have all of the lecture material online. You can find the slides in Sakai in the resource tab. And then you can find the code. I believe I uploaded it to the GitHub Classroom, so you should be able to just pull the code from GitHub so that you can follow along with me today. Again, I'm really excited to be here. This is going to be awesome. We're talking about the model view design pattern today. But before we start talking about that, I kind of want to take a step back and think about 401 as a class, Comp 401. And so the first half of this course was really like a primer in object-oriented programming. We kind of got a lot of experience with interfaces, classes, polymorphism, inheritance, and, all that kind of stuff, encapsulation. So that was kind of the first half of the class. And then the second half of the class, we kind of pivot a little bit and we talk about design patterns. And so honestly, this is why I'm so excited to be here today, because design patterns is my favorite part of Comp 401. You might be wondering, what is a design pattern? We've already talked about a few in this course. We've talked about singleton and iterator, I believe. Design patterns are techniques for organizing your code, and they're often used in the real world. So these are kind of tried and true techniques for organizing your code. This is kind of to try to help you when you start writing, an assignment and there's a blank method there and you have no idea what to write in that blank method. Design patterns are to try to help you to structure that code and to know where to start when you're tackling a assignment. I have this cheesy slide in here. The analogy that I like to give about design patterns is you can think about building your program as like building a house out of bricks, and the individual bricks are like your code, words that you learned, your keywords, like, if statements and classes and for statements. These are your bricks. But it's not enough to just put a bunch of bricks together, right? You need to actually order them in the right way in order to make your house be sound and pretty. And in the same way, when you write a program, you need to order your code in the right way and organize it so that it will, be sound and, is less susceptible to bugs and other things like that. So that's kind of my little silly analogy. Like I said, we've already talked about a few design patterns in this course. We've, I believe, talked about iterator and factory already, and then we have a few more coming up. Today we're going to be talking about model view. And the good thing about model view is it kind of is wrapped up a lot with observer observable. So we're actually going to see a lot of observer pattern, wrapped up in our model view design pattern. So this will kind of be like a review of observer observable, and at the same time, we're going to be seeing a new design pattern in model view. Any questions about that? Another thing, I love questions, so I'm going to try my best to ask for questions periodically throughout the lecture. Please, don't hesitate to ask questions. Usually when you are thinking about something, the rest of the class is also wondering that same thing, so questions are great. Okay, so this is going to kind of piggyback off of the color chooser widget lecture that we had a couple of weeks ago. Maybe it was last week. And so remember, we were just kind of getting our feet wet with Java GUI design, right? User interface design. And we talked about AWT Swing, which are Java's, so what is AWT Swing? These are Java's built-in libraries for making user interfaces. So if I say UIs throughout the lecture, I'm talking about user interfaces. AWT and Swing are these built-in libraries, and they consist of about 200 different classes, which all implement various UI components. So you have buttons, you have sliders, you have pictures, basically anything that you're normally used to interacting with on a computer in terms of like a user interface, like a graphical user interface. AWT and Swing have a component designed and ready for you to use for that. The thing for me with AWT and Swing is these are kind of massive libraries, or at least they feel really big, right? Because there's 200 classes. It can really get overwhelming, and it's like, how do I remember all these different classes? Um, the thing that I want to point you to here is the documentation. So no one, like, it's really hard. It would be really hard to memorize 200 different classes, and you are not expected to memorize 200 different classes. An awesome thing about programmers is they're resourceful, and so that includes you guys. And so resourceful meaning we know where to look to find the resource that we need. We might not know it on the top of our head, but we know where to go to find it. And so the AWT and the Swing documentation pages have kind of long descriptions of all of these different things. And so you don't have to memorize them, but just as soon as you need to use one, maybe you need a button or something, then you can go to this website and you can look and kind of glance down it and find the button section and read about the button and how to use it. And so, so I just wanted to point out this resource for you because it's great, and I recommend using it instead of memorizing it all. The Swing documentation is similar. It's another page, and like I said, they're both linked back here on the bottom of the page in the slide. So today we're going to be kind of bringing back a couple of the widgets and a couple of the components that we used back when we did the color changer, the color changing assignment or lecture. And so in particular, we're going to be using a few of these AWT and Swing concepts. So we're going to use a JPanel, which is a class that allows you to create a window. This is kind of just the basic window. And if you remember, we talked a little bit about this last week. The JPanel has two different types of layouts that we're going to use. We're going to use these today. And so the border layout is where you can position content. This is all about positioning content in your window, right? So the border layout allows you to position content, north, south, west, center, and east. So that allows you to position 1, 2, 3, 4, 5 different pieces of content, and you can align them in whichever position you want out of those 5 positions. Whereas the grid layout allows you to kind of supply a grid of elements, and it will position them automatically kind of like in rows and columns. And you can specify how many rows or how many columns you want to use. Another one that we're going to use today that maybe we talked about last week is Border Factory. And so Border Factory is just a simple class that we're going to use that allows us to add a little border on the outside of an element. So you can see all these different examples of different borders that you might want to put on your component. And so we're going to be doing that today. We'll get to that later. I'll show you how that works. But so the idea is Border Factory is another thing we're going to use. And then a new one for us today is JScrollPane. So JScrollPane allows us to make a scrollable, basically we just take an element that maybe is a long element, right, like a list of things, and then JScrollPane allows us to kind of make it scrollable with a little scroll bar on the side. Again, we're going to see examples of all of these in a few minutes. Does anyone have any questions about that? Okay. And so a few more that we may have seen before as well are, so if you look at this little example of a screenshot of a UI component, you see it has a first name and then a little box where you can put in your first name, and then it has last name, and then a little box where you put in your last name. So just to kind of point out what these components are in AWT Swing. The first, these little name things, this is a J label. I believe we saw this last time. So you can kind of put text in random positions on your interface. And then J text field is another one that we're going to use today. And so this lets you type text into a little input box. And then J button, of course, I think we saw that last time. J button is, this is a button that you can click, and this uses the observer-observable pattern, which we'll talk about in a second. And so the idea is when you click on the button, Java will execute one of your methods and it will notify your code. And so your code gets to execute in response to the user pressing that button. So that's kind of the idea behind a J button. And then JSlider we saw before. This lets you select a value. Right, so we kind of used some of these components in the past to, or, last week to make this little color picker app, right? And in particular, this widget that we did last week showed Java's AWT Swing API, and it also showed the observer design pattern. And so that's, again, like I said, we're going to keep coming back to that a few times this lecture. And so basically the idea behind the observer pattern, right, if you remember, is you have two different objects. You have an observer object and you have an observable. And the observer is interested in something that's happening in the observable. And so what will happen is as soon as something happens in the observable object, the observable will notify the observer by calling one of the methods. And maybe for instance, you changed the slider and you changed it from green to yellow. And then when that action occurs, the interface notifies your code and it executes a method on your code. And so this kind of gives you as the observer the opportunity to respond to the event occurring. You guys are going to be experts in observable by the end of this lecture, for sure. Again, yeah, the observer design pattern is very common, specifically in user interface development. So this is kind of what the code looked like for the color chooser widget. And I'm just going to point out a couple things in this code that's going to kind of motivate our design pattern that we're talking about today. So first of all, you'll notice that the color chooser is a class that we made, and we specifically made it into a JPanel component. So this class is a panel. It is a user interface. So inside of this class is a bunch of code related to the user interface, right? And in particular, we're going to listen to keyboard events and slider changes. We're actually, not only are we going to be displaying content to the user, but we're also going to be responding to changes in, when the user makes changes and presses buttons, we're going to be responding to that change. And so the color chooser is responsible for both displaying the content and for responding to the changes. So those are two pretty big tasks that we have. And so you'll notice that there's a lot of instance variables that we have to define in order to do both of those tasks, right? And so these instance variables, their job is to store the state of the widget. And so that's what they're going to do. But there's a lot of them because there's a lot of state involved. And then finally, the constructor, I also put that on the slide here. Again, this is kind of cookie cutter, object-oriented programming. Whenever we see a constructor, its job is to set the initial values for the instance variables. And so since we have lots of different instance variables, we have a lot of things to do in the constructor here, right? We have to set the initial color, and so you'll see the little init color thing there. So you have to set the initial color of the widget. We need to set up the widget UI components. And then we also need to set up the observers so that we can respond to the, the user's input. So kind of the point that I'm trying to lead up towards here is that this is kind of a lot to do in just one class. And so you might want, so the whole model view that we're building towards is an improvement on that, on the existing app that we already did. And so in particular, I want you to imagine a case where we have a more complicated widget, because the color picker that we did right there was pretty easy, right? There wasn't very much going on there. It was really just one color and then a slider bar. There wasn't too much going on. But you can imagine that it will easily, you could easily get a more complicated widget. And I mean, like, you all probably use Spotify. This was what I was listening to last night when I was writing this slide. just think of all of the different things that this app needs to deal with, right? There's a lot more than just a little color. And so you can imagine that that class would be massive, right? If you were going to make one class to do all of this stuff. And so the big idea that we're leading up towards here with model view is we kind of have two different things going on that our little color widget was doing, both of them in the same class, right? We have state, which is the data that represents the data that we're trying to present. And then we have presentation, which is like the UI components that present the data to the user. And so the whole model view paradigm is we're going to kind of try to separate those two ideas, the data that we're trying to represent, and we're going to separate that from the presentation of that data. So the model view design pattern, before with the color chooser widget, you would have the user interface and the application data and methods for manipulating the data, right? So when you change the color, right, when you move the sliders around, you were changing the color values. And we had to write code in that class to adjust the color values according to what the user was sliding. And so that would be kind of considered data manipulation. So all of these things were all done in the same class. Two of these represent the state of the system, which is the data in the system, and then the user interface is really just all those J labels and J panels and stuff. That was all just display, right? That's all view. And so that's just how we present the data. And so the idea is for model view, we want to move the application data and the data manipulation. Can you guys hear me? Good, sorry. We want to move the application data and the data manipulation over into a separate class. We kind of want to split those into separate files. And we're going to call that class the model. So then that leaves the view class with only the code necessary to manage the user interface. And then we kind of separate out the state, like the data, and we put that in the application in the model. And so the model is going to do two things, right? It's going to store the state of the application, which is the data. And then the model is also going to allow methods. It's going to provide an interface for manipulating the information. And so the model is kind of responsible for making sure that the data stays in a valid state, right? And doesn't go into an invalid state. And so the way that the model does that is by providing methods that can be used to access the data and change the data. And so kind of our glue, now we have two different things, right? We put the data on one side and we put the user interface on the other side, but they still need to interact with each other, right? So how are they going to interact with each other? We're going to notify, so we're going to actually use the observer pattern. And so the view is going to notify the model when a user interacts with the components. And then the model will have the ability to update the data appropriately, maybe check for invalid entries. Maybe if the user typed in an invalid entry, the model could look at that invalid entry and say, "Nuh-uh, no, I'm not going to accept that value because that would put me in an invalid state." So this kind of allows our model to focus on making sure that the data stays intact and correct. And then we're also going to have a return observable thing going on here, where the model can re-render the view, and the model can kind of update the view and notify the view when the underlying data changes. So this would be the model. Maybe if someone changes maybe we have a color. Maybe this is the color widget, right? So the color, which is the red, green, blue values, those would be stored in the model. And then the view can, adjust those values and notify the model that those values should change. And then whenever those values change, then the model can go back with the green arrow and update the view to, make it look the new color, make the new color appear. So there's kind of this bi-directional communication going on. Also, keep in mind that this is great separation of concerns because it allows the model data to be accessed from someone else, right? Like you could actually, technically, if you needed to, you could chop these two into separate pieces, the model and the view, and then you could use the model with some other application, right? The model is really just going to be the fundamental data that drives the widget, whereas the view is going to be the way that we're going to use that data to display on the screen. So the observer design pattern is going to be really important here. We're about to go through an example, but does anyone have any questions about this? This is kind of the theory part of the lecture. Yes, thank you. So he's asking if they are both a view and the model are observables, so they're each observing each other. And yes, that is, so I think when we actually implement this today, we're only going to make the model be an observable, and then the view will observe the model. But you can think of it as them both observing each other, them both being observables. We're going to use actions because the view itself is going to respond to actions from the user interface elements, like when you click a button, the view is going to respond to that, and then the view is going to call the model. So we're not going to be using the actual interface observer, but it is the same pattern, like it's the design pattern observer, because we're going to be, calling a method on the other object to notify that object that something happened. That was a really, really good question. Thank you. Any other questions? Okay, so the example that we're going to go through today is a song playlist, right? Kind of like the Spotify thing, except not quite as pretty. So the idea here is this is what the user interface is going to look like when we're done. We're going to kind of have a list of songs that you can see. It's a little small, so I'm sorry about that, but there's a list of songs. There's a button to shuffle the songs if you want to shuffle the order. And then at the bottom, you can add a new song by filling in its details and then clicking the plus button in the corner to add the new song to the playlist. And so we're going to, this is just kind of how we're going to structure this in code. Because you might be looking at this and you think, however is this going to turn into like lines of code? That seems hard. But so if we take it like piece by piece, it's not that bad. Overall, we're going to make a class called a playlist view, and that's going to store the entire user interface. That playlist view is going to be a J frame, right? What is it? A J panel, sorry. It's going to be a J panel. And so that J panel is going to have 3 components, which you can see in those 3 colors. It's going to have a component at the top to handle the button. It's going to have a component at the bottom to handle adding new songs to the playlist. And then it's going to have a panel in the middle for listing the songs in the playlist. And so each one, and so in this green little circle here, right, the J panel that's listing all of the songs, this is going to actually be made up of a list of smaller widgets, right? So each, it's purple, each little song in the list is its own class. And so this is going to kind of separate it out for us and allow us to focus on one, little piece of the app at a time. So what I really want to ask, and what I want you to be thinking about is, don't worry about the user interface yet. Let's think about the model. And in general, this is a good technique, is to think about the model first when you are going to design a user interface and you're going to do the MV pattern, the model view pattern. It's a good idea to consider the model first. So what's the model going to be for this app? And so in other words, that means what data state is presented by the view. What data do we want to put? What data drives this widget? And so the answer is, it's just a list of songs, right? And so you might imagine that would be stored in a list of song objects. And each song is going to contain a couple different things, right? It's going to contain a title, it's going to contain an artist, and it's going to contain a rating. And so the rating is like 1 to 5 stars or something like that, right? Or 0 to 5 stars. And so this is just, I'm making this up, right? I'm defining this as part of the example. This is what the song is going to look like, and this is what the widget is going to have. It's going to have a list of these songs in it. And so before we start jumping into code, I do want to point out that there's a few symbols here that we haven't really talked about. So I talked a little bit about all the J labels and the little interfaces that we're going to use. But in addition to that, we're also going to use these symbols, right? Like there's star symbols, there's the arrow symbols, and so we haven't really talked about that yet in this course. But there is this encoding for lots of different glyphs, and it's called Unicode. And so you can use Unicode to insert a lot of different symbols into your user interface. And so you can look this up by just searching on Google for Unicode symbols, and you can see a long list of all the different Unicode symbols that you can use, and each symbol is attached to a code that represents it, right? And so you can see that in the upper right-hand corner there, the blue. Those are the symbols, like the code that we're going to insert in order to make those symbols appear on the screen. Unicode is widely used and it's widely understood. It's been around for a really long time. And so as a result, a lot of different applications actually support Unicode. So you could actually copy and paste those symbols into a Word editor or into Google Chrome. There's lots of, it has very wide support. So without further ado, let's go and look at the model. And so I'm going to switch over to Eclipse to look at the model. So again, the code should be accessible from GitHub on the, just our GitHub Classroom. And so the first example for lecture 18 is just the model. And so you're thinking about how you're going to represent the data. And we talked about two things on the last slide, right? We talked about representing the playlist as a list of songs. And then, so let's think about an individual song first, right? So if you go to the song .java file in our first version of the example code, you'll see that we have a really simple class that encapsulates the title, the artist, and the rating in private instance variables. And then the constructor here is very, again, I use the word cookie cutter. It's very cookie cutter object-oriented programming that in the constructor, what you do is you set the initial values for the instance variables. And so we're going to set the title and the artist and the rating as whatever gets input to the constructor, right? So we're going to accept a title and an artist and a rating, and then we're going to store those internally as our values. And then there's some simple getters and setters, right? Get title, get artist, and get rating. And all these do is return the internal values of these properties. And then I want to talk down here about this toString method on the song class. So the toString method will generate a string representation of the song. We're going to use this to output, in our song list, the string representation of the song with the stars. And so you'll see that this class, this method is pretty simple. The important part is this for loop. This is the interesting part, right? So the point of this for loop is to take your star take your star rating and convert it into a list of 5 stars, right? And so the idea is some of these stars are going to be filled, and then some of these stars are going to be outlined. And so each time we go through the loop, we are only going to output one single star. And so you'll see this for loop goes from 0 to 5, so that's 5 stars total. And then each time it goes through the loop, we are only going to output 1 star. And so basically we're going to output a bunch of filled stars first until I gets large enough, right? So I starts out at 0, and then I will increase And while I is low, while I is below the rating, then we're going to output filled stars. And then as soon as I gets higher than the rating, then we're going to output, like the outline stars. And so that way it'll make that pretty little star thing where it has like the filled stars and then the unfilled stars. And you can see how many, stars the song was given. And so we build this up into a string called rating string right here. And then at the end, we return a concatenation of all the different strings. So that's right here. The title by artist, and then the rating string that has the stars in it. And so you'll notice that you can just use this code to output a filled star. And this is the Unicode part. U2605 represents a filled star, and 2606 represents an outline star. Any questions about that? There's other ways to do this too, right? Like this isn't the only way. This is just a way. So if you were thinking, I would probably approach this a different way, that is totally okay. Okay, so I'm going to switch over to the playlist.java file in the first lecture, the first example. And so this is just a playlist class, which again, this is the model, right? So this represents an ordered playlist of song objects. And so you'll see that, what do we need? And so when you're writing this class, the first thing you should think about is, what do I need to encapsulate? What private variables, what instance variables should I have in this class? And so this playlist represents a list of songs, right? And so that's why we would think, oh, okay, so the playlist has a list of songs in it, so that's why you add a private, instance variable that represents the list of songs. We're going to encapsulate that inside of the playlist class. And so again, the constructor is very cookie cutter. We're just going to initialize our songs variable, our instance variable, and we're going to start it off as an empty array list. So we initialize songs to just be an empty new array list of songs. So to start with, there are no songs in the playlist. And then we have a couple normal, NetBeans getters and setters for our properties. Like for instance, you might want to get the size, which is the number of songs in the playlist, and that just returns songs.size, which is the number of songs in the playlist. I thought this method was interesting. So this allows you to get a list, like an array. It allows you to get an array of the songs in the playlist. And so the way that this works is we're going to convert our list of songs into an array of songs. So you'll notice that songs, if we go back up to the top, songs is a list of songs, right? List. Whereas this getSongs method returns an array of songs. And so we need to convert from the list to the array style. And so the way that we're going to do that is by calling toArray, which is built into the list interface in JavaScript, or in Java. And so the idea here is that this is going to take in as input a empty array of songs, and then this toArray method will fill in the songs. And so the whole point here is that this is going to return a duplicate of the songs array, just so that we protect our version of the songs array inside the playlist. This is part of the encapsulation of the songs array. And then a method to add a new song to the array, remove a song from the array, get a song from the array by index, shuffle the songs by just shuffling the order of songs in the list. And then finally, an option to move a song from one index to a different index in the playlist. And so we're going to use this method to kind of, sort the playlist with those arrows that are going to allow you to move the songs up and down. And so here's where we're doing some array checking, so some array bounds checking. We are checking to see if the input to this method is valid or not, right? So you can't insert a song at an index below 0, and you can't insert a song at an index larger than the size of the song of the list. And so this is where we're going to check to make sure that the input is valid. And so this is an important part of the model, right? The model is going to ensure that the data remains intact and it remains in a valid state. So if someone tried to move a song to an invalid location, this method would say, hold on a minute, like, no, you're not allowed to do that. And then it would, prevent that action from taking place. And then finally, once we check to see if the song, indices are correct, then we actually do the operation which will move the song and swap them. Any questions about that? So one thing here is that I created a lot of different methods, right? Like there's a lot of different methods here. And, how would you know if you were going to start making this app, how would you know to write all of these methods? So I kind of want to talk a little bit about that. Right, so those methods that we just went through on the playlist object, those methods allow external code to access and manipulate and get access to the data that is stored inside of the playlist. So the purpose of the model is to A, store the data, but also B, provide methods for data access and manipulation. So for our example, we have a playlist, which is a list of songs, and each song has a title and an artist and a rating. And then we provide all of these methods to access and manipulate properties on the playlist. So for like get size, get songs, add song, move song, get song, shuffle, move song. These are all the things we just looked at the code for. And the point is, I have those arrows pointing in because you could imagine that someone outside of the playlist, right? So like our view, for instance, our view might want to call those methods and use those methods to call the and to manipulate the data on the playlist. So the point here is that the view is manipulating the data, and the view is the one driving the manipulation of the data through these methods. Any questions about that? This is very much encapsulation, right? This is a lot like what we learned about with object-oriented programming, where you make all of your variables private and then you provide accessor methods to allow external code to manipulate the values. That's what we're doing here. Okay, so now we're going to start talking, we're going to kind of circle back to the user interface, the UI stuff. And now that we have the model taken care of, we're going to go and go through the view, right? So this is the user interface stuff. So in code, like I said before, we're going to split the playlist view into 3 different pieces: the button panel, which has the shuffle button on top, and then the list panel, which has the list of the songs, and then a song widget at the bottom, which will allow us to rate the songs or add new songs to the list. And so, like we talked about before, each one of those songs in the list panel will have its own little class associated with it, so that we can kind of manipulate each little piece of that interface in a different file. So we're kind of separating out into different files here. And this is kind of what the structure will look like. We're about to go back to Eclipse and look at this code. Does anyone have any questions about the diagram? Okay, let's go look at what it looks like in Eclipse. So the second version of the lecture examples has two new classes. It has main and it has playlist view. So let's look at playlist view first. Playlist view is, again, this is just like with the color choosing widget. Playlist view is an object that extends JPanel. So playlist view is itself a JPanel. That's important. And so the job of the playlist view is to be a JPanel and present all the information inside of our app. And so this was, in the diagram on the slides, this was the blue outer circle, box around the whole thing. So our view here is going to encapsulate a playlist. So it's going to keep an instance, it's going to keep a pointer, a reference. It's going to keep a reference to the model. And so the view has a model inside of it that it's encapsulating. And so this is how we're going to access the model and how we're going to update the values of the model. And then also we're going to encapsulate a JPanel called list panel, and this list panel specifically represents the panel in the middle that holds all of the lists, or that holds all of the songs. It lists the songs. So again, our constructor, the purpose of the constructor is to set up all the properties. And so we take in as input a model, right, the playlist, and then we store the playlist, we store a reference to the playlist so that we can use it to construct the view, and we can also use it to update when the user changes the interface, presses buttons and changes stuff. And so here we're going to set the layout of the JPanel, because remember, we are a JPanel here. So this is equivalent to doing this dot set layout, right? We're calling set layout on ourselves on this. So we're setting the playlist views layout. And so we talked about the different kinds of layouts. There was a grid layout, and that was where you align the internal components in a grid. And then the other one was border layout, and that lets you define the components with north, south, left, right, and center. I think, or no, east, west, and center. East, west, and center. So the border layout is what we're using in order to specify where the internal components should go. And so that's what this line does. It just specifies that we are going to use border layout to align our items. So what items do we actually want? Well, like we said, there were only three, right? There was a button at the top that said shuffle, there was the list in the middle, and then there was the widget at the bottom. And so I think in this example, we're only going to start with one. So right here is where we're eventually going to, eventually we'll have shuffle here. And then down at the bottom, eventually we'll have add song widget here. So the point is, with this example, we just kind of want to set something up, right? We want to show something on the screen. We want to test our code to make sure that what we're doing is right and that there are no errors. And so that's why we don't have any of this functionality in there yet. But for now, all we're just going to do is we're going to create our list panel, which will be, the panel in the middle that has this list of songs in it. We're going to go through that list of songs. And we're going to, so that's right here, this for loop right here on line 31. We're going through the list of songs. And for each song, we're going to make that song into a JLabel. And this is because you can't just insert a string directly into the user interface. Instead, you have to wrap strings in a JLabel. And so the JLabel is the, that's kind of the abstraction for a string that you want to display on the screen. So we go through the songs. For each song, we create a J label that represents that song. And you'll notice that we're using s.toString here, right? So we're converting that song to string, and this will call that method that we looked at that generated the little stars, and it generates and it concatenates the string together, so it has the title of the song and the artist and then the rating. So that gets called right here, and the result is a string that represents the song, and we're going to wrap that string in a J label, and we're going to add that J label to this J panel called list panel that we're building up. So list panel is a J panel, and inside of list panel is a list of, it's a bunch of different J labels, which are the song titles. And then once we're done with that, we add list panel to us, right? So this is equivalent to doing this dot add. We are adding list panel to, we created list panel right here, right? This part right here just creates list panel. Now it exists. We filled it with song labels, but now we just have a floating out in space. We have a list panel. So we need to actually add that list panel into the window. And so that's what this last line does right here. This adds that list panel into the window, and we're going to make it in the center position out of all of those positions for the border layout. So there's a little bit of funky user interface code here. Any questions about this? Yes, thank you. Oh, great question. Thank you. Yeah, we didn't talk about that, and I forgot to. You're awesome. So she's asking about this line right here, which is listPanel.setLayout. And we didn't actually talk about this, and it's new grid layout. So this is, we have to specify what kind of layout we're using for our JPanels, right? And so we have two JPanels in this code that we're looking at right now, right? The outside class, playlist view, is itself a JPanel. In addition, there's a second JPanel that we create right here called list panel. And so the outside JPanel is what kind of layout? It is a border layout. And so that is the one where we can specify center, east, west, north, south. But the list panel, JPanel, is going to be a grid layout. And so we use set layout just like we did up here, right? So this is just a call to set layout up here. And we're going to do that same thing on the list panel. But for the list panel, we're not going to use border layout, we're going to use grid layout. And so the grid layout, remember, is kind of like a grid of items. And this tells the computer to, order the items in rows and columns. And so the way the grid layout works, it takes two parameters, and that represents the number of rows and the number of columns to create for your grid. You'll notice that we said 0 here, and that's kind of funky, right? Why would you want to have 0 rows and 1 column in your list? That doesn't make sense. But if you read about grid layout, it allows you to make it says right here, but I think it's really tiny. So I'm just going to read this. One, but not both, of rows and calls can be 0, which means that any number of objects can be placed in a row or in a column. So if you specify 0 as one of these two values, it will basically just make as many of those as it needs to in order to fit the content. So basically, it's kind of like lazy evaluation. It's going to lazily decide when to, how many rows there should be. So it's going to not right away know how many rows there should be. But based on how many songs you put in, that's how it knows how many rows there should be. And the number of columns is fixed at 1. So there will only ever be 1 column, and the number of rows will depend on how many songs you have. Really, thank you so much. That was important. Does that make sense to everybody? Any other questions about that? Yes? You can always add more, yeah. So something that we're going to talk about later is when you do want to add more, kind of at a later time, you have to worry about repainting the user interface. So once it paints the user interface, and we're about to see this right now. So let me just use this as a segue into the next part. We're going to switch over to the main.java part of this same example, and we're going to show how we use the playlist view in order to create, the window and show the content. So we're going to make a JFrame, which is, this represents the window. This was kind of, we talked about this last week. And then we're going to set the title of the window to be playlist view example, and we're going to set the default close operation, and this is just what should happen when you click the X button on the window. And so what do we want to do when you click the window X button? We want to exit, so exit.close. So that's all that this line tells you to do. Then here we're going to actually create our model. This is where we create the playlist. So we create the playlist and we add a bunch of songs to the playlist using the model methods, right, that we created. Add songs, so we're manipulating the model by adding new songs. So that's what's going on here. And then here's where we create the playlist view, right? And so we're calling the constructor on the playlist view, which is up here. This is back in the playlist view. You'll see the constructor takes as input the model. And so we pass that model into the playlist view, and that goes right here. So we pass our model into the playlist view. And so now we have a playlist view, but we need to add that playlist view into the window, right? And so that's what this next line does. This next line adds the playlist view into the window. And then finally, we need to actually display it to the screen. So mainFrame.pack and mainFrame.setVisible will actually make the thing appear visible. So this is kind of code that you could just copy and paste when you're using to make your own user interfaces. A lot of the, this is what it does. This is just the interface that Java defines for how to interact with a window. Again, yeah, you don't have to memorize it all. It's really just, it's there for you to, to kind of copy and paste and use in your own applications. So what I was getting to here is the main frame doesn't actually show on the screen until you call this pack and then set visible. So when this set visible gets called, this is when it gets shown to the screen. If you make changes to the model after this, like down here, make changes here, then they won't immediately get, it's not synchronized where they will immediately update on the, in the window. We are going to have to add a method here to repaint the frame on, and kind of tell it to refresh what it looks like. And so we'll get to that in a second, but that's kind of, I think, where we were going towards with your question about can you add more elements to the grid layout? Good question, thank you. And so we can run this, I hope. So I'm just going to go run as Java application, and I guess I'll save them. And so here it is. It's kind of hard to see because it's small, but you can run this on your own computer and you can see that we printed out the strings. Now remember, we haven't actually made the widgets yet. So far, all we've done is output the, like the J labels. We turned the strings into, or we turned the songs into J labels and we output them to the screen. So that's what you see here. The next example that we're going to talk about, instead of just doing J labels, we're going to actually do objects and a class so that we can have all those buttons. So let's go ahead and switch to the slides and we'll talk about that. Okay, so back in the slides, the next thing we're going to talk about is making these widgets, right? Instead of just doing the J label, we're going to do a whole widget with a song, or with all the song information. And so we're going to create a new class called a song listing widget. And that class is going to have two components, right? It's going to have a J panel on the left, which represents, it'll be over here, and that represents the button panel. And then on the right, it's going to have a J label, which will be exactly what we had before, right? Before, we just had the yellow part, which is the list of the song title and the song information. But now we kind of want to add this green part on the left that represents the buttons. And so that's why this button panel is going to be a J panel, and inside of that J panel will be a list of buttons, right? So we're going to add buttons to that J panel. And then secondly, we're going to add another class called Add Song Widget. And that class is going to be, it's going to be another widget. It's going to be another J panel that has inside of it some J panels, and it has some text fields. And this is kind of the new thing we're going to talk about today, which is the text field, which allows the user to type in it. And then it also has the rating slider, which is a J slider, which is just like the color wheel, the color picker slider widget that we used before. And then also a button for adding a song. Once the user fills in all of these values, they press this add song button, and then it will, and then our code will execute to insert the song. So right now, we're not worrying about how the code will execute. Right now, we're just worrying about how to put the content on the page, right? And so this is just the view. We're doing view coding right now. So I'm going to switch back to Eclipse, and we're going to look at how what I just showed you looks in code. Okay, so now we're in example 3. And everything is pretty much the same, except now we have two new classes. We have Add Song Widget, and we have Song Listing Widget. And so those are the two things that I showed you the diagrams for on the slides. Does anyone have any questions about those diagrams? I think I forgot to ask about that. Oh, yeah. Oh, that's a great question. I'm going to switch back to the slides so that we can talk about that. In Song Listing Widget, why do we have 3 buttons here instead of, and why did we wrap that in a panel? So he's asking why in the Song Listing Widget, why do we have, we have those 3 buttons and then we have the J label. Why do we wrap the 3 buttons in a button panel? And it's a really good question because all of these all these elements are going to be kind of in a row, right? And so you might think that you could use, we have to lay out this content, right? And we have 3 buttons and we have 1 J label. How are we going to lay out that content? We have 2 layout managers that we've talked about so far. We have a grid layout manager, and we have the other one, what was that? Thank you. Yeah, border layout. And so the border layout allows us to specify, that's not what we want here, right? We have a list of items. We want to use a grid with, 1 row and no columns, and then that would allow us to kind of have a list of content, which is just like what we were talking about for in the last example with the grid, the grid layout with the 0 and the 1. So we could do that here. The reason that this is a little bit better is because by grouping the buttons together, it allows them all to be kind of like together, right? Like shifted together in the page and on the left side. If we didn't have that button panel, then it would just spread the content out across the entire width, and it'll just kind of like try to equally assign widths to each one of the contents. So the buttons would be bigger. The buttons would be the exact same size as the J labels, and it would kind of look a little funny because it would spread the content out across the line. Whereas this way allows us to specify all the buttons together in one little piece and then specify the J label as the second piece. Does that make sense? That was a really good question. Thank you so much. Any other questions while I have the slides up? Okay, so then I'm going to go back to the code, and we're going to look at the song listing widget. So again, this is going to encapsulate the playlist. It's going to encapsulate the model. We're going to see this a lot. But in addition to encapsulating the model, we also need to encapsulate an idea of which song is being listed, right? Because this song listing widget is going to represent one of the songs. And so we need to know which one of those songs we are presenting. And so that's why we're also going to encapsulate a private index, which represents the song that we're displaying. So that's how we know which one. And so the constructor here, again, this is cookie cutter object-oriented programming. We're going to store and we're going to store initial values for our instance properties, and then we have to worry about setting up the like the user interface. And so how are we going to do that? Well, we are again in and of ourselves a JPanel, right? Yeah, we are a JPanel right here. So the song listing widget is a JPanel, which means that we need to specify what border, or no, what layout to use. And so that is this set layout. We're going to use a border layout for this. So this is where we do like north, south, east, west, center. In addition, this is a new line right here. We're going to set a border around this JLabel, this JPanel. And so this set border is, remember in the slide before I talked about how you might have borders around your JPanels. This is how you do that. It showed a picture on the slide of about 10 different borders. And so this is an etched border. And so it has a particular look and feel about it. There are other ones that we could use instead. We could look online and find a list of all the different borders. We're going to use an etched border for this example. So that defines how the JPanel looks, but now we need to kind of add the content inside of our song listing widget. And so that's what we're going to do here. We're going to create a JLabel that represents the song string, which is just like what we were doing before. But now, in addition to adding that JLabel to the string, or to our content, we also want to add a button panel. And so that's what this code down here does. We're going to make a button panel, and then we're going to add buttons to that button panel. We're going to add a remove button, an up button, a down button. And in particular, for the up button and the down button, we're going to use Unicode again here to specify the up arrow and the down arrow. And so you have to look up these commands to find out what Unicode symbol code represents the down arrow and what one represents the up arrow, but that's what we're using here. And so these are creating new buttons, and here inside of the button constructor, we specify what the button should be labeled as, what should be inside of the button. And so finally, we add the button panel to our JPanel. Again, this is the same thing as doing this.add. So again, very it's a lot of code, but I mean, it's pretty repetitive a little bit almost. And the same thing with add song widget. Again, this is going to extend JPanel. So this widget is itself a JPanel. It encapsulates the model. And then it's going to encapsulate some various user interface components. This is the add song widget at the bottom of the app, and this allows you to add a new song to the list. And so for that reason, we need a song field and an artist field, which are the places where the user can type in the song name and the artist name. And then we also need a slider so that the user can specify whether they want 0 stars, 1 star, 2 star, 3 star, 4 stars, or 5 stars for the rating. And then we also have an add song button. And this is after the user fills out the content, they press this button and it adds, and once we finish, it will add it to the list. So here's the code for that. Again, we're just kind of adding these user interface things, and then we are adding them to the JPanel. We're making a slider. Here's some configuration for the slider. And then the button. Are there any questions about this? Like, we could go through this, but it's very similar to what we were looking at already. Questions are great though, because that allows me to focus on the interesting part. Okay, then let's just run this. And so this allows us, this will show us the whole user interface. But we haven't done anything to handle what the button, when you click on stuff, right? So that's kind of the last piece is all these buttons, they don't do anything, right? All these buttons are here and it looks great. You can shuffle and, you can type things in down here. But none of these buttons actually cause anything to happen. And so that's going to be the last part of this example. So let's switch over. Oh yeah, I'm sorry. Thank you so much. I'm sorry? Did I cover JSlider? These right here, the constructor. Oh, I'm so sorry. So the JSlider constructor. Good question. So the JSlider takes in 3 parameters here as input. What is this? And it refers to how many ticks there should be. So we want 5 tick option. I think it goes from 0 to 5. And I don't remember what this third one represents. Let's look that up. Oh, I don't have internet down here. It's the initial value. Thank you so much. Okay, so the 0 and the 5 represent the tick marks. So we want the slider, it could go all real numbers if you wanted it to, but we want to limit it to between 0 and 5 stars. And then I guess this third one is for the initial value, which is 0. So that's where the starting point is. Really good question. Sorry that I didn't have a great answer. Any other questions about this code? Okay, so we're almost done. We have one more thing to talk about. So what is the flow going to look like? We need to update things, right? When we click the buttons, we need things to happen to update it. And so this is the interface that we made, and we finished it. And now we kind of need to hook it up to the model, right? And so how are we going to hook it up to the model? We defined these, this interface that the model supports, like these methods: shuffle, remove song, move song, and add song. And so really what we want to do is we just want to make it so when you click shuffle, the view will call the shuffle method on the model. When you click an X button here on one of the songs, we want to call the model remove song. When you click the up button or the down button, we want to call move song. And so there's kind of a nice correspondence here between the model, and so that's why we defined these model methods the way that they did. But maybe if you were designing this yourself, you might want to go back and now add some more methods to the model to support the actions that you think you're going to need in your view. And so basically, this is the behavior that we want. One last thing to talk about here is when a user clicks on these buttons, not only do we want to shuffle the model, but then we also, for instance, if you click the shuffle model, not only do we want to shuffle the list, but then we want to update the user interface to show that the list was shuffled. And so there's this is kind of like that return arrow back in that slide, the green arrow on top. the model needs to, push updates back to the view. And this is where we're going to use an observable observer backwards to tell the view to update your methods, to update the view, to update the way it looks. And so that's why we're going to have, this is where we need that return arrow. And so the view, when update gets called, the view will, re-render and repaint the interface. So this is kind of the flow of information using the observer pattern. And so let's go back to Eclipse and we'll talk about that. Okay, so we're in the last example now, and we're specifically going to look at our views, right? So let's look at add song widget and song listing widget. So I'm going to go to add song widget first. This is the one at the bottom that allows you to add a new song. And so you'll see that we added this implements action listener. And so the action listener is what we, this is what we need to add to our JPanel if we need to listen to events from the user interface. So this is when a button gets clicked, we want to respond to the button being clicked, right? And so we need to register ourselves, we need to register the add song widget as a listener, as an observer of those events, of, the event of someone clicking the button. And so that's why we need to implement this action listener method interface. And so then down here in our constructor, down at the very bottom, we need to add. So we need to kind of register ourselves. This is kind of the registration process of the observer. Again, this is kind of like review from the observer pattern. We need to register ourselves as a listener. So we're registering ourselves, this, as an action listener, and we are listening to the song button being pressed. The other thing that's new here is we have multiple buttons in this example. We have, oh, no, never mind. We only have one button in this example. So we're just going to add our listener. And so when by adding ourselves here, we're adding ourselves as a listener to the button. What does that mean? Well, it means that we have this action performed method, and this action performed method will be executed as soon as the button is pressed. So that this is part of the interface defined by action listener, and the action listener interface enforces that it forces us to put this action performed method in here. And so this is what happens when the button gets pressed. And so this allows us to, modify, this allows us to respond to the action taking place. And so we're going to pull out the data of the song that the user put in, and we are going to create a new song right here, new song, to create a new song, and then we're going to add that song to the list. And then finally, to our model. This is where we call the model method and update the list by adding our new song. And then finally, we're going to clear the values in the form down at the bottom so that you could add a new song if you wanted to. The song listing widget is similar. You'll see that we implement action listener again here. And the reason that we did that is so that we could register ourselves as listeners to each of the buttons. And so on this one, we have a remove button to remove the song. We have an up button to move the song up and a down button to move the song down. So we need to actually add ourselves as listeners to all three buttons. And so this is where there's a little bit of new code. When any one of these buttons gets pressed, it's going to execute this action performed method. And so this is how we get to respond to the button press. But in particular, we need to know which button got pressed. And so as part of the action listener interface, we can set and specify a string that says which button got pressed. And this just basically sends some information with the action event that's part of the action performed interface, or the event listener interface. And this allows us to figure out which button was pressed. and respond accordingly. So if the user pressed remove, then we're going to remove the song. If they clicked up, then we're going to go up. And if they click down, then we're going to go down. We're running out of time here, so I'm just going to go back to the main and show you that it works. I can take questions afterwards privately if you have them. But so now at this point, this kind of hooks up everything so that they all work together. And all, you can play with this together on your own computer as well. Oh, yeah. Hey, thanks so much.
So I'm a little confused on the difference between song and listen widget and the add song. So like the add song widget, like is this auto or is it like combination of
So the add song widget is going to be a view component because it's UI. Yeah, honestly, we probably should have done add song view. I think that probably would have been more clear instead of add song widget. But anytime you see like the extends JPanel, it means it's a user interface